C++ modifiers. In C++, modifiers are keywords that are used to modify the behavior of various elements in your code, such as variables, functions, and classes. These modifiers provide additional information about how these elements should be treated by the compiler or how they should behave at runtime. Here are some common C++ modifiers. So before we proceed, here are another example of common modifiers in C++. In C++, modifiers are keywords that are used to modify properties of variables and functions like const, volatile, mutable, and static. These modifiers provide flexibility and control over how variables and functions behave in C++ program. In common modifiers in C++, we have sign, unsigned, long, and short. So these are the functions of four common modifiers in C++. In sign, we have integer, char, and long prefix. And in unsigned, we have integer, char, and short prefix. And in long, we have integer and double. And in short, we have integer. So this is the functions of signed modifier. Signed variables can store positive, negative, integers, and 0. Example, signed integer a equals 4 semicolon. Signed integer b equals 67 semicolon. Signed integer c 0 semicolon. And here, a is a positive value integer, b is a negative value integer, and c is a 0 valued integer. Example, C++. In C++ program, to demonstrate the sign modifier, include IOStream using namespace std. Driver code int main, size of sign int, size of sign integer, bytes and line. Count sign char and sign of sign char, bytes and line. Return 0 semicolon. Output, size of sign integer 4 bytes, size of sign char 1 bytes. Unsigned modifier. Unsigned variables can store only non-negative integer values. Example, unsigned integer a equals 9. Unsigned integer b equals 0 semicolon. Here, a is a positive value integer, b is a 0 valued integer. Example, C++ program demonstrate to unsigned modifier include IOStream using namespace std semicolon, driver code int main, size of unsigned integer, size of unsigned integer, bytes and line, size of unsigned char, size of unsigned char, bytes and line. Return 0. Output, size of unsigned integer 4 bytes, size of unsigned char is 1 byte. Short modifier. The short keyword modifies the minimum values that a date type can hold. It is used for small integers that lie in the range of negative 32,767 to positive 32,767. Example, short integers x equals 4,590 semicolon. Example, C++ program to demonstrate a short modifier include IOStream using namespace std. Drive code int main, count size of short int, size of short int, bytes and line. Return 0. Output, size of short int 2 bytes. Long modifier. The long keyword modifies the maximum values that a data type can hold. It is used for large integers that are in the range of 2,147,483,647 to 2,147,483,647. Example, long integers y equals 26,936. Example, C++. C++ program to demonstrate the long modifier. Hashtag include IOStream using namespace std. Drive code int main. Count size of long integer. Size of long integer bytes. End line. Size of long double. Size of long double bytes. End line. Return 0. Output. Size of long integer 8 bytes. Size of long double is 16 bytes. Type qualifiers in C++. In C++, type qualifiers are keywords that are used to modify the properties of variables and their values. These qualifiers provide additional information about how variables should be treated or accessed within a program. Here are the main type of qualifiers in C++. Cons. The cons type qualifier is used to indicate that a variable is constant and cannot be modified after it is initialized. It provides safety guarantees and can help the compiler perform certain optimizations. Second, volatile. The volatile type qualifier is used to indicate that a variable's value may change unexpectedly due to external factors not known to the compiler. It tells the compiler not to optimize access to the variable, as its value might change outside the program's control. Mutable. The mutable type qualifier is used within a class to specify that a member variable can be modified even within a cons member function. This allows for changing the state of an object while not modifying its logical state. Volatile mutable. In some rare cases, you may encounter a combination of both volatile and mutable type qualifiers. This would indicate that a variable can be modified even within a cons member function and that its value might change unexpectedly due to the external factors.